Friends, welcome to ZimSeek Robotics Lab with the Zim Science General. In this video, we are going to discuss introduction to logic gates and the objectives for this topic is to describe logic gates. What are logic gates? Logic gates are devices in digital circuits behind the fundamental thinking and decision-making mechanisms relied upon by most robotic systems. What are the components of a logic gate? Logic gates are made up of transistors, diodes, and resistors. Transistors act as switches that can turn current on and off, and also they amplify input signals, making them stronger. Then we also have diodes, which keep current flowing in one direction. How do logic gates work? Logic gates work based on a combination of digital signals from its inputs to produce a single output, and most logic gates have two sensor inputs producing one output. Then input, what is input? Input is information given to the logic gate in the form of electrical signals. Then output is simply information that comes out of it. Inputs and outputs are represented by voltage levels. For a low voltage, which is equivalent to 0 volts, is a digital binary number of 0, which is low or false or off. Then a high voltage, which has got voltage of between 3 and 5, has a digit of 1, which represents high, true, or on. Then logic gates read these voltage levels to make fast and accurate decisions in robotic systems, e.g. activating the motor to rotate. We now want to visualize inputs and outputs of a logic gate. Let us consider an obstacle avoiding robot with an ultrasonic sensor A and a battery status sensor B, both being inputs. If these are on, and if it is true that A and B are true, output, the robot moves forward. In essence, logical gates translate electrical signals, zeros and ones, into logic or logical decisions which are true or false. A single logic gate can only do one function, e.g. switching on and off an electric bulb. To create more complex decisions and control systems, several logic gates are combined to make larger circuits of desired function or behavior, e.g. the behavior in humanoid robots. Let us now consider different types of logic gates Logic gates come in two main groups. We have the compound logic gates and the basic logic gates. Basic logic gates, we have the AND gate, the OR gate, the NOT or the NOT gate. Then we have compound gates, which are the universal logic gates made up of the NAND and NOT and other logic gates, which are the XOR and the XNOR logic gates. How do we visualize logic gates using our local examples? We can take a school gate with two locks unlocked by key A and unlocked by B to demonstrate how AND gate works. Consider that Shumba school gate is controlled by two different locks, lock A and lock B. Shumba High School gate controls the flow of learners into its premises. Learners are the input into the school gate, and it is the school gate that outputs learners. The table given on the next slide shows possible combinations. Only when it is true that key A and key B, it is true that you can open the school gate. Key A, key B, and it is true that you can open the school gate. When an action can be true or false, it is a binary relationship. The table similar to the one given above is referred to as a truth table. That is a table that represents output. What output will one get for a given input? Then we can also use our local example of Shumba School to demonstrate a logic gate called an OR gate. The laboratory door can be unlocked with key A and its spare key B. It is true that with key A, either key A or key B, that it is true that you can open the laboratory door. It is true that either key A or key B, that is, it is true that you can open the robotics lab. It is false that with neither key nor key B, neither key A nor key B, that it is false that you can open the lab door. And it is also easy and fun to demonstrate, to visualize a NOT gate. To visualize a NOT gate, we can consider the teacher's demonstration table. It can be considered that input and output, if the table can be inside or outside the lab. When it is true that the table is inside the lab, then it is false that it is inside the lab, and vice versa. Table for the NOT gate is over there. False, true, true, false. Then quick questions. Identify 3 logic gates. List 2 universal gates. 2 minutes to do it. Okay. For more questions on this topic, please watch the video on Introduction to Logic Gates and suggested answers in the comment section. See you there.